So in this part, we use definite integrals to find the area of some bounded regions. So we are given with a continuous function. Let f of x be a continuous function defined on closed interval AB. Okay, then area bounded by this curve y is equal to f of x, the x-axis, and the lines x is equal to A and x is equal to B. This area bounded by the curve, the x-axis, and the lines x is equal to A and x is equal to B, that is given by integral A to B f of x dx. Okay, or you can write integral A to B y dx. Area. Since area is always positive, we write integral A to B f of x dx, modulus of that. And this, it can be all the curve can be even under the curve x-axis. If it is like this is the curve y is equal to f of x, and the lines are can be x is equal to A here. Here is x is equal to B. This area also can be evaluated using the same formula. Area between any curve, the x-axis and the lines, modulus of A to B. So these two cases comes under this. Okay. Now in the case where if the curve is, if you wanted to find the area between the curve y is equal to f of x and the y-axis, this is your y-axis, between the lines y is equal to C and y is equal to D. Then this curve, given curve y is equal to f of x should be written in the form of x is equal to some g of y. So in that case, the area between the curve and the y-axis is given by, in that case, area is equal to modulus of integral C to D g of y dy. Okay, or that can also be written as modulus integral C to D x dy. Okay. Now, what are the steps? So, these are the three cases to find the area that can come for the exam. So, what are the steps involved to find the area under the curve? So, the first step is you have to draw the, first step one is draw a rough sketch of the curve. Draw a rough sketch of the given curve of the given function y is equal to f of x. So, what are the possibilities for the function? If the function given is a linear function in x and y, ax plus by is equal to c, that means that will be a straight line that you can draw on the graph paper. And if it is any one of the variables of degree 2, y square is equal to x or 4ax plus or minus 4ax, or it can be x square is equal to plus or minus 4ay, then it means that is a parabola. And in the first two cases, this is positive for x means right-handed or left-handed parabola. This is upward and downward parabola. And next possibility is, so this is first possibility, straight line or parabola, and the next possibility, it can be circle, x square plus y square is equal to r square. So that's a circle with center, origin and radius r, or generally it can be x minus h whole square plus y minus k whole square is equal to r square. In that case also that is a circle with a center at hk and radius r. And finally it can come like both variables of degree 2, but the coefficients are not equal. X square by a square plus y square by b square is equal to 1. Then it will be, or it can be, then this is a horizontal type of ellipse, and the other one it can be x square by b square plus y square by a square is equal to 1. Then that ellipse is whose major axis is along y axis. So in all these cases, Now you can see that. Then secondly, what you have to do is you just examine the curve. Which is the curve you have to find out and draw it. Draw a rough sketch of that. That if the curve is symmetrical about any of the axes, then find the area of one part and make it double. If it is symmetrical about both the axes, then find the area in one quadrant and multiply it by 4. Multiply it by 4. Okay. I repeat, if the curve is symmetrical about any of the axes, then find the area of one part and make it double. If it is symmetrical about both the axes, find the area in one quadrant and multiply it by 4. Okay. That's all about area. Okay.